We're going to continue on finding points of intersection, but now we're going to look at problem number 2. So we're going to focus on finding when f of x, which is x plus 7 times x minus 4, when would that intersect, or when is it going to equal g of x, which is x minus 4. So let's zoom in a little bit on these right here. And let's focus a little bit on f of x. That is a quadratic that's in factored form, and g of x happens to be a linear function. And we want to know when they're equal to each other. So again, I'm going to show you the algebra way, which takes a little bit longer. And then I'll go and use Desmos, and we'll check our answers using Desmos. So we have x plus 7 times x minus 4 equal to x minus 4. So I don't know if you guys noticed, but these two functions have something in common. They both have, actually I'll underline it, the same factor of x minus 4. And that's going to help me get my very first answer, or my very first point of intersection, which is going to occur at one of the zeros, 4. And I'll show you how this works out. So if I plug 4 in for every x over here, you're going to get 4 plus 7 times 4 minus 4 equals, and then on the right side, you're going to get 4 minus 4. So this gives me 0, this gives me 0, 4 plus 7, 8, 9, 10, 11, and that gives me 11. But we know that anything times 0 is just 0. And this is how you know that that's going to be one of my point of intersections. It's going to occur at 4, 0. Now we're going to focus on how to find another point of intersection algebraically. Since we've already figured out where one of them occurs, because they have that same factor, since factors mean to multiply, right? These are multiplying. I'm going to divide both sides by x minus 4. And I know you've never really seen this happen before, but because we've already figured out where that they share that factor, and we've already found that point where they run into each other, we can go ahead and divide both sides by x minus 4. Now this is going to basically cancel out. Anything divided by itself is really a 1. And anything times 1 is just itself. So this left side is just going to boil down to an x plus 7. Now on this right side, they cancel each other out as well, because anything divided by itself is just 1, but it doesn't cancel out and go away. We don't have a 0 there anymore. We have a positive 1. And now that's a really simple equation to solve. What number plus 7 gives me 1? It's got to be a negative number, negative 6. So that brings me to another point of intersection, which is going to occur when x is negative 6. You can plug it back into either function. You can plug it back into f of x if you wanted to, or you can plug negative 6 back into g of x to figure out where it's going to cross at the y coordinate. I'm going to choose g of x because it's easier. So when I plug negative 6 into g of x, you're going to get negative 6 take away 4, which is a negative 10. So there are our 2 points of intersection, so I'll rewrite them. We're crossing at 4, 0, and we're crossing at negative 6, negative 10. So keep those 2 points in your head. Oops, sorry for my screen flipping. Because we're also going to get our answers by Desmos, right? And we're going to put f of x into one of the graphs, right? We're going to put this into like y1. And then we'll put g of x into the second line as y2. So x plus 7, x minus 4. Let's go over here to my Desmos. So y equals x plus 7, x minus 4. There's your quadratic. And then the other one, y equals, I think it was just x minus 4, right? Because they shared that factor. And there's my linear function. And we're going to have to zoom a little bit here and check it. Boom, 4, 0, negative 6, negative 10.